Introduction to PLCs. Before PLCs, there were relays. The problem with relays was not only their size, but they were extremely slow. Speeds were as slow as 20 to 60 milliseconds. If changes had to be made, rewiring would be required. Electricians had to understand relay logic and be able to troubleshoot electrical control systems using electrical schematics. With the advancement of the transistor, logic gates were replacing relay control circuits. The digital revolution was born. The explosion of digital control systems and computers placed new demands on the technician. As the digital age continued to accelerate, so did the need for qualified electricians. Learning Boolean algebra was a new skill maintenance electricians had to learn in order to troubleshoot. Most companies kept the relays until Hydromatic, a division of General Motors, requested a device that would, number one, adapt to change, number two, be able to be placed on the factory floor, and number three, the programming had to be done in the form of relay logic, a method that plant electricians, engineers, and technicians were already familiar with. Dick Morley is given credit with inventing the first PLC, but Alan Bradley copyrighted the letter PLC. In 1970, the first PLC was installed at General Motors' Oldsmobile plant at the Landis Company in Landis, Pennsylvania. Today, PLCs come in a variety of sizes based on approximate I/O count. So, what exactly is a PLC? Best definition, a PLC is a computer that takes the place of relays and wires. Relays with normally open and normally closed contacts are replaced with memory locations that resides in a processor. The program in a PLC appears as a line diagram. The symbol used mimic relay logic, and each symbol has a specific memory address. The normally open, normally closed, and relay coils is nothing but text on the keyboard. Symbols have a specific memory location. It's all virtual. There is nothing real about it. Relay logic has real voltages, real normally open, normally closed contacts, and real outputs. Ladder logic has symbols that mimic relay logic symbols, has specific memory locations, and the program appears as line diagrams. The challenge of troubleshooting PLCs is the same as it was almost 50 years ago. To realize, although there are similarities between relay logic and ladder logic, troubleshooting PLCs cannot be approached with the same mindset that is used for troubleshooting relay logic. Failing to make a clear distinction between the two will only add confusion and frustration. Presently, the PLC industry is and has been attempting to move away from relay logic programming, but is finding to do so difficult because of its early marketing. The analogy would be like saying, if you speak Spanish fluently, you should be able to speak Italian. Speaking in Spanish will only give you the chance to identify and understand some words, and maybe whole sentences, but does not mean you can go to Italy and understand the language. Essentials for troubleshooting PLCs will introduce you to the 6 fundamentals for troubleshooting with success and confidence. A second course that is in development is designed for hands-on lab exercises. This course will build on the foundation that is presented in Essentials for Troubleshooting PLCs.